Welcome. This screencast helps us look at vector motion in a plane. We have been looking at parametric motion in a plane, and what that's meant for us is that we've had this XY plane and some particle traveling like so. Now, if you're a Calculus 1 student, you're very interested in what's the slope of the tangent line, what's the slope of the tangent line, and that's all well and good. But we're Calculus 2 students, and so we get to think about what if there's a particle that starts here and it moves in the plane like this? If the particle is moving in the plane, then it has a velocity, it has an acceleration, it has a speed, and these are all things we have to know how to find. So let's do that. Let's imagine that we have some parametric curve like so, and it's got equations where x is some function of t and y is some other function of t, right? And the motion maybe goes this way. And we're interested in, well, what is the velocity of the particle? Well, velocity, when you're measuring one-dimensional motion, well, yes, when you're measuring one-dimensional motion, velocity is a number. It's a speed with a direction. But when you're in 2 dimensions, velocity is a vector. It's a vector, and it's a vector where we have the derivative of x and then the derivative of y, telling us how the horizontal distance is changing and how the vertical distance is changing. This almost makes sense to have dx dt and dy dt be the components of a vector, because at this particular moment in time, the particle is moving along a vector. And how do we determine that vector? Well, we look at how far we're moving horizontally and how far we're moving vertically along that vector. So velocity is a vector. Dx dt, dy dt are its components. Why is that important? Because speed comes from a direct corollary of what velocity is. In the plane, we can measure speed as the magnitude of the velocity vector. When we had one-dimensional motion, we just took an absolute value. That's the magnitude of a vector. So we take the magnitude of this vector to get speed. Speed is the square root of x prime of t squared plus y prime of t squared. So speed's a number. It's the length of that vector. It's the magnitude of that vector. And curiously, it's the thing we integrate to get arc length, which shouldn't surprise us at all. I'll write it over here. The total distance traveled is the integral from A to B of speed. Why does that make sense? If we integrate speed over a time interval, we should get the total distance traveled. These are Calculus 1 ideas that we can now apply in a Calculus 2 context. One other thing we should think about. We should think about a particle's acceleration. If a particle is going to accelerate, it also accelerates along a vector. We can no longer think of acceleration as a number. Acceleration is a vector. At this particular point in time, how is the particle accelerating? Well, whatever x double prime is and whatever y double prime is. Why? What do vectors allow us to do? Vectors allow us to break motion up into a horizontal component and a vertical component. So when we look at acceleration, we're looking at how is the horizontal velocity changing? How is the vertical velocity changing? How is this changing? How is this changing? And we can consider those separately because vectors allow us to break motion down into a horizontal component and a vertical component. We can treat them differently. So these are the important things for you to know. You have to know that a velocity vector comes by taking the derivatives of those position equations, that acceleration comes from taking the derivatives of the components of the velocity vector, that speed is a number, it's the magnitude of the velocity vector, and that arc length is what you get when you integrate speed over a time interval. These are Calculus 1 ideas in a Calculus 2 context. So this is what you need to review before an exam. I will do another screencast that breaks down how this has looked in times past on Calculus 2 final exams, on an AP Calculus BC exam, sort of a thing. And that may be helpful to our viewers also.